Welcome to the L'Hopital's Rule Homework Help video. All right, so I'm going to just go over the problems, just give you little hints as you're working on these. So this would be a good video to watch if you get stuck on one. All right, so the first set, and I didn't have this as a PDF to be able to just cut and paste in, so I wrote it in there for you. You're finding techniques from chapter 1. That means the techniques we started with in terms of finding the limit. And then B, you're going to use L'Hopital's rule. It says use L'Hopital's rule so you don't have to justify. But remember, if this were an AP test, you need to, or test, you need to justify that you can use L'Hopital's rule by showing that the limit is indeterminate because the numerator approaches 0, the denominator approaches 0, or the numerator approaches infinity and the denominator approaches infinity, or so forth. Right? But it specifically states use L'Hopital's rule, right? So you don't have to justify. As a little reminder, in terms of the techniques from chapter 1, I'm going to give you a hint. All right, so on number 1, so this is for A. All right, so for A, factor and reduce is the correct technique. For A, on the second one, multiply by the conjugate. And remember, the conjugate is the exact same thing. So square root of x plus 1, but it's going to be a plus 2 instead of a minus 2. Right? And then, of course, the middle drops out, and you'll have something that you can reduce. So after you multiply by the conjugate, you can then reduce. So you'll simplify and reduce. Yep. All right, and then for the third one, for the A part, using the techniques that you learned at the beginning of the year, you're going to divide all terms by the highest power of x. I didn't give myself a good amount of space. This third one is all cramped in here now. The highest power of x. Right? And then you'll reduce. And remember that if you have a constant, actually I can't fit that in there. Let me write it up here, the little reminder. All right, so here's the little reminder. The limit as x approaches positive or negative infinity of a constant over any power of x. I still don't have enough space. Just a little bit more equals 0. All right, so you can use that to find the limits. On the other ones, you're going to use, for the B part, you'll use L'Hopital's rule. Boy, I don't have much B on the space on the last problem there. This one is straight power rule for finding the derivative. Remember, when you're using L'Hopital's rule, as a reminder, take the derivative of the numerator and derivative of the denominator. Right? And then keep doing that. So I'm going to continue what I'm writing over here. Keep doing this until the limit is not indeterminate anymore. There. All right, so on B, you can use the power rule, right? And then once you use the power rule, remember, once it's no longer indeterminate, then you'll substitute, right? You'll substitute 3. define the limit. B here for number 2 is also a power rule. And actually, so is C. All of them are power rule. Some of them, though, you may have to do more than once, but all 3 of them are power rule, and on all of them, you'll then substitute. I could say B for every one of them. And I'm actually going to, oops, I don't know why I put BC. I meant to put 1, 2, 3, but I'm just going to make this B here, 1, 2, 3. For all 3 of those, you just use power rule and substitute. Remember on 2 to rewrite that in exponential form. All right? So that's this set here. All right, we'll go through some of these little helpful hints. Now, notice that it says, if possible. All right, so some of these you cannot use LHopital's rule for. Because it says evaluate by using LHopital's rule, I will just have you justify when you cannot use LHopital's rule. Okay, so we'll do it that way. I'm not going to tell you which ones you can't use LHopital's rule for, but some of these are just not indeterminate. All right, and that's what you're looking for. All right. See if there's any little helpful hints I should give you in terms of taking the derivative. All right, so derivative hints. All right, so 4 is power rule, both numerator and denominator. 5 is in the numerator, is a chain rule. The outside function, so you'll rewrite that square root as 4 minus x squared to the 1/2. So the outside function is a power rule. But then you have to multiply by the derivative of the inside function, which is also a power rule. You got to multiply by the derivative of 4 minus x squared. Number 6, you've got derivative of e to the x. Oh my gosh, that is just the easiest derivative of all, right? And a power rule in the numerator, because you've got x to a power. Simplify this first. You've got that. I certainly wouldn't make that a chain rule. I would just simplify, distribute the negative, right? Actually, maybe I only need 1, but you'll know to distribute that negative, right? So I would simplify that negative, and then you've got derivative of e to the x, and you have a power rule. By the way, before you do just find the derivative, don't remember to make sure the limit the limit is indeterminate, because you can only use LHopital's rule when the limit is indeterminate. Come on, letters. And then the denominator is pretty easy. That's power rule as well. So that's a pretty easy one. All right, so 7. And by the way, I am giving you what the derivatives are. I am not guaranteeing you, just because I tell you what the derivative hints are, does not mean you will be using LHopital's rule. So do not in any way assume the fact that I'm giving you derivative hints means that the limit is indeterminate. Right? So they may all be here, and actually they do look like they're all indeterminate from the first 5. But I'm going to give you hints. However, you make sure the limit is indeterminate first. All right, that's key. And the derivative hints are if the derivative is indeterminate. Because I'm not going to do the work of telling you which ones are or aren't. Oops. I guess I can't move. Ah! I hate when that happens. Undo the ungroup part. I wanted to just move that stupid line up, the if possible part. Boy, that does not want to move. Oh, that likes to move. I'm just going to get rid of that. All right, you see if possible. And now let's just move this up. Oops. Ah, the joys of working with the mouse. Never does. Come on. Just move in the right spot. There. Good enough. Good enough. Good enough. This is if the derivative is indeterminate. And if it's indeterminate, then these are the derivative hints. Okay? Just so let's make sure we're clear on that. All right, so maybe I'm giving you derivative hints for a derivative you're not going to be taking. All right, so we have some trig derivatives, specifically sine. That is a chain rule. So actually, I'll just put sine. Sine derivative and chain rule. Right, the inside function is the 2x and the 3x. When you take the derivative of the outside, that inside does not change, right? So it's the derivative of sine blop. The blop, 2x and 3x, remains unchanged. And then take the derivative of the 2x and the 3x. And by the way, after this video, if you have any more questions, feel free to email me. We can work together, right? And I can help you individually. 8, you've got in the numerator, just the derivative of arc sine. And if you forget, go look at your notes. I mean, eventually you got to memorize these, but you can always look back at your notes to remind yourself. And then in the denominator, I'll just do this. You have a power rule, a really easy derivative there with x. Right? And some of these you may have to do more than once. Right? I'm not going to go through what the derivative is for the second shot. And if you have questions and you get in contact with me, email me. All right? Leave a message on, and I misspelled arc sine. Leave a message on the discussion board, etc. Okay. There we go. All right, let's look at the second group. All right, so 9 more derivative hints here. If they are indeed indeterminate, we have just a straight power rule. A little hint, this one is more than once. I'll give you that hint. I don't know if I notice any of the others being more than once. Probably not. I'm not guaranteeing them. I don't have the key in front of me. I'm just kind of eyeballing them. 10 is also a power rule. And remember, all of these are if the limit is indeed indeterminate. And you have all the limit types, the indeterminate limit types in your notes. The only ones I've seen so far have been number 11 is a power rule as well. In the numerator, nice easy power rule. But in the denominator, it's a power rule, but it's also a chain rule. Right, you need the derivative of the outside. The outside function is x squared plus 1 to the 1/2, so that's blop to the 1/2, and then take the derivative of the blop. The blop is x squared plus 1. So this is a chain rule with the power rule. I guess that's the best way to call it. Because your outside part function is a power rule and the inside function is a power rule. 12, you have the derivative of natural log of x, which is a nice easy one. And really nice on the simplifying. And then a power rule. So that one's actually a really easy one. All right, so let's look at the last bunch, or maybe the second to last bunch. I think there's another part. On 13, you have a chain rule in the numerator with natural log of x, with the derivative for natural log of x. So the chain part is the block cubed, right? So you're taking the derivative of block cubed. So that's technically a power rule. So I'll put power rule in there. Power rule and natural log of x, because you've got block cubed, take that derivative, all right, and the blob stays the same, and then take the derivative of the blob. The blob is a natural log of x. And then in the denominator, you simply have a nice, easy power rule. 14, you got to rewrite that, all right? So a little hint, all right? And you're going to need to rewrite it before you even determine whether or not that's indeterminate. But negative x is also equal to negative 1 over x to the negative 1. All right, so a little hint there. And the derivative will be the derivative of natural log of x. And the other part's a chain rule. Excuse me, power rule. Same thing on 15, all right, so I don't know why I switched to green. I might as well just stay with blue. All right, so 15x is the same as 1 over x to the negative 1, and then you've got derivative of sine in the numerator. That is, though, with the chain rule, because the derivative of 1 over x is not 1, right? So you'll need to rewrite that x in that case when you're taking the derivative of sine 1 over x, you're taking the derivative of the x to the negative 1. So 1 over x is x to the negative 1 is what I meant to write. All right, and then so that'll be a power rule with the sine rule there, right? So you have the derivative of sine blop, the blop remains unchanged, and then the derivative of x to the negative 1 on that part, right? And then the denominator is power rule. (16), before you can do anything, you have to take the natural log of both sides. Excuse me, not both sides. There is no both sides of the limit. I've been doing too many with solving equations, I guess, too many videos with solving equations. Take the natural log of the limit, so you can use the power rule for logs. And that can be done whether or not the limit is indeterminate. And ta-da! There we go. You can use the power rule for logs to move the exponent. Right? The exponent will become a coefficient. Right? And then you may need to simplify, or may not. Right? But you'll need to do that first. Right? And that will just move your exponent as a coefficient. All right? So there's this group, and then let's look at the last group. Right? And so just remember, all of these are dependent on the limit being indeterminate. 17 is the same thing if this is an indeterminate, but either way, you can use LHopital's rule if it's an indeterminate, but either way, you've got to move the exponent. So you'll need to take the natural log of the limit. Oh, and as a reminder, if you take the natural log of the limit, just a little reminder, then the limit, you have to undo that. So the limit is e to the limit, right? Whatever your answer is, it's e to that limit, right? Because e to the x, making an exponent, taking an exponential of something, undoes taking the natural log of it. And so you're going to take a natural log of the limit. You got to then exponentiate. Right? So after you take the natural log of the limit and you find your limit, don't forget to exponentiate afterwards. Right? So it's going to be e to the limit will be your limit, your actual limit. All right? And 18 and 19, if they are indeterminate, they are type infinity minus infinity. Regardless of whether they're indeterminate or not, you're going to do the same thing for both of those. You need to rewrite as one fraction. Right. Make sure you, to make it easy on yourself, make sure you have the least common denominator. Right? So one of those factors is repeated in both denominators. So in question 18. So you're going to rewrite as one fraction first, then determine if it's indeterminate. It's hard to look at a limit of infinity minus infinity and notice it right away that it's indeterminate. But if you rewrite it as one fraction, then you can see, right? It's a limit as x approaches 2 from the right and as x approaches 1 from the right. So if it's indeterminate, it's going to be 0 over 0 type when you rewrite it as one fraction. Right? So then determine if limit is indeterminate. And that would be the numerator. In this case, it'd be the numerator approaching 0, denominator approaching 0. And if so, you can use LHopital's rule. You've got both of those are combination is power rules, the power rule, and then of course in 19 you have natural log of x, that's 19. And then 20 is in the numerator, it's power rule. In the denominator, it's e to the x, but with a chain, because you got to take the derivative of the exponent there, 5x. All right, so I hope this helps you in finding these. I think that's the last one. Let me see. Do I have anything? Is there? Oh no, I'm not. No, that's not it. Right? Did I skip any? Oh, did we skip 4 and 5? Did I go right to and not even notice that? Nope, there's 4 and 5. Oh, those other ones, I think I had it going horizontally, and then I decided no, vertically would be easier to write. So that should be the last one. If you have any questions, again, email me or use the discussion forum. But I hope this helps you out in knowing how to set these up. And remember, my derivative hints are only if the derivative is indeterminate. I will guarantee you this, at least one of them is not indeterminate. All right, so at least one of the 20, actually not 20, from 4, one of the 17, from 4 to 20. The first 3 were indeterminate. But from 4 to 20, at least one was not indeterminate. All right, well, thanks for watching. Bye for now.